Hello all. I wanted to show you an example of finding a limit through cancellation. So the very first thing we're going to try to do with any limit that we encounter is we're going to try to put the limiting number in. And hopefully the limit laws will permit us to finish the job right there. We're going to get an answer and we will be finished with the problem. Most often this doesn't happen. So let's go ahead and take a look at the problem at hand. Right now we're taking a look at the limit of this function as x approaches a -4. So when we try to put a -4 into this function, hoping the limit laws are going to work, we try to put a -4 into this function, we end up getting -4 squared, which is 16. This is going to be minus 28, and then plus 12. All of that adds to 0. So in the numerator, we get 0. In the denominator, we try to put -4 into the denominator. We're going to get -8 here for this term, and 8 over here, so the denominator will add to 0. So right now, if we try to put the limiting number in, we get 0 over 0. Now, this number doesn't really exist. So this tells us that we are unable to use the limit laws with this limit as it is written. We need to do something else. We need to rewrite this limit in some way so that we can apply the limit laws. So this is what we're going to do. The reason why we're getting 0 in the numerator and the denominator is that we have an additional factor of x plus 4 in both of them. And this additional factor is turning the entire thing into 0. So let's take a look. So we'll go ahead and write our limit again. We have to do this every time. So we'll go ahead and we write our limit again. And our numerator is going to factor into two separate factors. One of them is going to be an x plus 4. I know that this x plus 4 is going to be here because when I put -4 into a polynomial and get 0, there will always be an x plus 4 there. This is always going to be true for any polynomial and any number down here. So if there was a 2 down here and I got a 0 on the top, I'd be looking for an x minus 2. If there was a 7 down here, I'd be looking for an x minus 7. Because there's a -4 down here, I'm looking for an x plus 4. I'm looking for whatever is going to make this into 0. So I know there's an x plus 4 on the top, and I also know that there's going to be an x plus 4 in the bottom. But there's more here. I need to be able to factor the bottom and factor the top. And so the top is going to factor into an x plus 4 times an x plus 3. The bottom is going to factor into an x plus 4 times 2. And if we need to check our work to see if we really factored correctly, you can always just multiply all of this stuff through. So we factored everything out, and we see there's this common factor of x plus 4 on the top and bottom. What we're going to do is we're going to consider a different function, and we're going to consider the function that looks exactly like this one, except we have removed the x plus 4s. And so we have the x plus 3 all over 2. So we've removed the x plus 4s by considering a different function. Because the only difference between this function and this one is those missing x plus 4s, these two functions are going to give the same output no matter what number goes in there, with the exception of -4. These two functions differ at exactly one point, and that point will happen when the x value is at -4. Because these two functions differ at just that one point, their limits are the same, and this is why we're just allowed to casually cancel out these x plus 4s. Normally that's a bigger problem, but because we're dealing with limits, not an issue. So, we have seen the common x plus 4s, we cancel them out, and we're left with this x plus 3 over 2. We have revised our limit to something that's simpler to use, and now we hope the limit laws are going to work. So, we try to put the -4 into the function again, and hope that we can get a good output number, and we'll be finished. So we put a -4 in here, and you get -4 plus 3, which is -1 on the top. You put a -4, well, there's no place to put the -4 in the denominator, so there's just a 2 in the denominator. And we have a -1/2, and this is our answer. So you see over here, we could not use the limit laws because you ended up getting an answer that didn't make any sense whatsoever. 0 over 0 is not a number that we can use. It is not defined, and so we have nowhere to go here. Limit laws are failing. So what we do is we take a look at why the limit laws are failing, and they're failing in this case because of a common factor on the top and bottom. We remove that common factor on top and bottom. We're allowed to do this because we have a limit in front. And once we've removed that common factor off the top and off the bottom, we can try the limit laws again. And when we try them again, they work just fine. So this process is relatively short when written, but there's a lot of math that goes into it, and you shouldn't neglect any of the steps that go on the way to this point. So anyway, thank you much for watching, and happy mathing.